again, guys. Welcome along to part 6 of this It's a Miss engine I'm doing. In this part we're going to do the piston and the rings as I mentioned in part 5. But I found, just doing it from memory all the time, what I thought, I forget, it's not easy to remember everything. You think of a dimension, you might be laid in bed or having breakfast or whatever, and then by the time I've got in here I've forgotten. So I've sat down tonight, I've done a bit of a better drawing of the piston and how I think I need to cut it all away, etc, etc. So without further ado, we'll take it across and we'll show you that, and hopefully we'll get the cast iron piston ring made in this part as well. Okay guys. Right, so I've been doing a little bit more drawing tonight of a more accurate description of the piston rather than just the scribble that I did. So we know it's 25.4 millimeters diameter, which is 1 inch. I'm going to make it 35 millimeters long. Why I've decided on that, I can't tell you, I just have. I'm going to leave a 2.5 mil at the top, a land at the top, then I'm going to cut the first groove. And that groove's going to be 1.6 millimeters wide. I'll tell you the reason why, because I don't know if you've seen some of my previous videos, but I made a rare parting tool, and I had these that had been given, these right thin HSS parting tools, and at the time I'd actually made a holder for it. I've 3 different holders for 3 different types of blade for that parting tool, so that fits in there. It's got a bit right way around because that is actually an angle at chamfer, because that blade's got right slight bevel on it, and that blade is 1.6 millimeters wide, so that's the width of the piston rings that I'm going to make. Okay, so we've got I'm going to put 2 piston rings on it and gap them right, hopefully. I've got to groove the depth of the piston 2 millimeters deep, which again I've just guessed and thought that's maybe right. I know a lot of them on these models they do a lot thinner than that, but I've decided on that. If it don't work out, well, we'll have to make another piston. We've got the gudgeon pinhole, which is going to be 5 millimeter reamed, and I've got the piece of silver steel for that, which is that 5 millimeter rod. That'll be the, excuse the camera bash, the gudgeon pin. I'm going to nip the gudgeon pin now. I was going to try and make an HSS tool that would groove this to put circlips in the end, but I think I'm on a hide into nothing on that. That would be so difficult to cut a flat groove around in that internal bore to hold circlips. So the next best thing I've come to, a lot of the model guys, they drill that through, or drill the ends of it, and they make Delron buttons that press in the end, and it sort of locates it. Well, it don't locate it, it's still floating as the gudgeon pin, but it can touch the side of the cylinder wall without actually doing any damage. But again, I'm not doing that. I'm going to run this, as you know, in a needle roller bearing in that. So this is the piston, a shot from the back. So I'm going to cut a 1 millimeter counterbore in it to a depth, counterbore to 10 millimeters deep, counterbore 10 millimeter deep to 23 millimeters diameter. Okay, to 23 millimeters diameter. Okay, so that's going to be a counterbore, and then further down the piston, of course, I'm going to mill this away to get this conrod in, to accept the conrod itself. And I've allowed what I think is enough wiggle room, because this is going to be pivoted there, and it's going to move 16 millimeters either way in its crank throw to give the 32 millimeter total. So I'm sure it's going to clear everything in here. I've mocked it up and I think it'll clear. If not, I might have to remove some more material here, but I'm hoping there's enough wiggle room there for it to rock. Obviously this has got to be round because I'm boring it. On the other way would be to use a very small milling tool in the corners and then gently cut away like that to get a more square cut. I haven't ruled that out completely yet. We haven't got that far. So some of this work, I'd say half of it's got to be done on the lathe. So I've glued up the piece of metal and that'll go in the lathe like that. My plan is to not remove anything off this. This is a finished piece, and start boring what I need to do. I also need to do my piston rings. So there are 2 piston rings to do, and then I mark off where I'm going to part it off and decide whether I'm going to part it off at that point or not, and put it back later and part it off and take it over to the milling machine and start doing the work in the back here, which is this work here, what you've seen. The only thing I haven't shown is I'm going to do M2, but I haven't got M2 tap, but I have got M3 screws tapped. I've got M2 and M3 Allen screws, so they're going to nip the conrod. So the conrod will be fixed to the piston, if you like. It won't be able to move, and it'll only move in the needle roller bearing, which is fine. Okay, cut slot 10 millimeters, so 10 millimeter cutter to 19 millimeters wide total, and 25 millimeters deep, which will take me down to here, which should be okay. I've left 4.5 millimeter for conrod clearance. From the edge of the conrod there to there is 4 millimeters, so I've left 4.5 millimeters to give clearance so the conrod can't touch the end of the piston, the inside of the piston. I think I've covered all the bits on that what I need to show, and the next thing will be to go over, set camera up and go over onto the lathe and make a start of it. Yeah, it's 10 to 10 at night now and I'm going out in morning, so I think I'll probably wrap for tonight, but at least it's a start of part 6 of what we're doing. At least we're getting somewhere. So we finished the liner in part 5, so that's okay. Sorry guys, I got carried away and I ended up cutting these 2 grooves. So basically what I've done is I've put that little parting tool in that I showed you, 1.6 mil, and I've marked 2.5 mil from the end of where the piston's going to finish at 35 millimeters, which is there, and that's where it'll be faced off. And then I've cut first groove 2 millimeters deep. Now I've gone 2 millimeters and I don't know if it's too deep. The reason being, you've got to spring these cast iron piston rings over that piston, and if 2 millimeters too deep they'll snap. I won't be able to spring them over, in which case I'll have to start all over again and make the piston again. I've got enough material to do it, but I'd rather not. But yeah, I mean, they've got to be a snug fit in there, so the rings are going to have to be 2 millimeters thick, and I might have bitten off more than I can chew there. I might have been better off if I'd have made them maybe 1.5 millimeter. We'll have to see. Springing piston rings open, not always dodgy. So I've cut both grooves to 787 thou 2 millimeters, whichever you want to go with. Next job would be to bore the back of it here, which I'd said from my drawing I've got to counter bore it, so it's only 1 millimeter thick, up to a depth which was a predetermined depth. So counter bore 10mm deep to 23mm. So I've got to cut 23mm diameter and 10mm deep, so it's not a lot. The reason for that, it's only that. The reason for that, of course, is there's got to get a gudgeon pin in here and you need strength around it, and I've got to have the room to drill the two little grub screws that are going to hold the gudgeon pin in. So as I said, the two grooves are cut in the lathe, the parting off will be done in the lathe, the counter bore that I'm going to bore up here will be done in the lathe, and there'll be nothing to stop me running a drill through the centre up to my depth of where the 10mm slot's going to be, but that's going to have to be done on the milling machine. I've left all this length on here and I wasn't going to part it off for a simple reason that I might need work holding, some sort of way, V-blocks or whatever, to hold it in the milling machine. I did opt for the 4-jaw. Now my 3-jaw grip through would have done it quite amply. The reason I didn't is the through hole in here is 1 inch, and it took this 1-inch bar, which goes quite a way back here now, does this bar. My 3-jaw chuck, it's only about 3/4 of an inch, and it wouldn't have taken that stock. Does that matter? Well, not really, but it does, because if I mess this up, I've got that next piece there spare to make another piston. Having said that, I've also got a bigger piece there that I could turn down, and I've got some much bigger pieces. I've plenty of aluminium around that size in the scrap bin. They're all scrap pieces, scrap ends, but I'm hoping I don't need to. So far I've not wasted anything, and I'm hoping in this build we don't. I'm sure at some point we will. We all make mistakes, and it is 11:15 at night now. I said I wasn't going to do this tonight, and that's why I hadn't shown it, because I got on with it and forgot all about the camera, setting this thing up with this blade and everything. But it's cut admirably. That Ray tool post has been absolutely fantastic. The Myford always used to jitter and judder, and I'm sure it's because I've got a compound quick change tool holder, all fastened onto a cross slide. You've got, you know, 3 items there plus the tool holder itself. That's 4 items, all that can flex and go wrong, whereas with that there's nothing. It's direct on and that's it. And yeah, it cut absolutely superb. I wish I could have shown it, but it was only in aluminium, and I'm sure you might have seen it before. Okay guys, I'll knock that off at that, and we'll come back tomorrow at some point when I come back from brekkie with my mates, and we'll do some more to it, probably bore it. I'll edit that out. Let's get that straight again. Sunlight's that bright in here, I can't see whether you can see. So I'd measured from the edge of the conrod to my depth I needed, and I said it was 4mm, I think. That's incorrect. I need to measure from the centre of the conrod for the depth I need, and I think it comes out at 9. Yeah, I've remarked it here, 9mm. I got it as 4.5, so I've altered that to 9, and we'll check it, see if that's correct when I've got there. So this here, there's nothing to stop me boring the centre of this to depth, and that's saying cut a slot 10mm, to 19 millimeters wide, which we've already said, and now it's deeper, it's 29 millimeters. It was 25 before, so I need to drill a hole 29 millimeters deep. The piston's 35 long, so there's plenty of room there. 29. Ruler. I'm going to call that 0. 0, that DRO, so I need to go in 29 mil. So I've now drilled a pilot hole, if you like, down the centre. I could mark this for parting, but other than that I think it's got to come out of there now. I think we're done. It'll be over to the mill to do the GoPro at the same time, so you can see what I'm doing on this thing, the arrow. That's kicked and we're on Y, so 0 Y, in fact 0 everything, but 0 in Y specifically. I know where I've gone on X, so bring it off the table, go to the other side and do the same. 0, let's bring it to 0 and then we know exactly it's the same spot where we were. Okay, so that's exactly the same spot. I'm going to come off now till we get a kick on this thing again. We've got one there, but let's do it slower. Turn that off now. So it's showing 30.530 because there's the thickness of the edge finder. So I'm not pressing this button, it's Y that we want to find centre of, so I'm going to put Y half. That's telling me the centre of my work is at 15.265. Take it to that and see if it tells truth. So we need to go to 0, and if we're at 0, technically we should be absolutely centre of the work for where the gudgeon pin wants drilling. Right, that can be locked. It certainly looks central. But it's $500,000 under what the size we're shooting for anyway, so it shouldn't matter. I'm putting some oil on. I know it's probably gummy and sticky, but that's what I'm doing. And we've bored to depth at 29mm. And we've bored that to 10mm and counterboard. But all this is now got to be travelled away. But that's what we're saying to you. Because I've reamed this to size, I can now get a work holding and know that that wants to be at 90 degrees to this rod. So my slot wants to go up and down on there. That'll do for me. It says after 4 minutes, 5 minutes. It doesn't matter how long it takes, as long as it's right when you've done. So technically we're dead centre now with that. Now, I need to go to a total of 29. Another 9. on now. Right, the conrod won't go in, and it's because of the corners which I talked about, the radius. So I have an alternative here. I either trim some of this down, the conrod, which is easily doable because it's way oversized. That'd drive a 250cc motorbike with that. Well over engineered. So if I radius them two, it would fit, because there is clearance there, right, a little bit, which is what I wanted. So do we work on the piston? That hole off camera. I've cut the gudgeon pin to length, and it's just slightly shorter, so it ain't going to encroach on edges there. I measured from the inside of the piston and the inside of the slot and halved it, but when I looked at it, it didn't look right clever, so I've eyeballed it what I think's better. So that the head of an M3 will clear in there once that's tapped. I've drilled that clear. I'm going to now drill this one clear, and I'm at 15.725 millimeters from the first hole. When I've done that, I'm going to insert the pin, center it and hold it, and bob the drill down again, just to mark these ends. I'm afraid if I push that through now and drill through, it might wander, might the drill. So I'm going to drill this hole now. Through clear. No spotting drill, but it is only a 2.5 millimeter, which is the tapping drill for 3 millimeter M3 thread. I'm going to go smaller, but M3 tap, I'll probably snap it. It says M2, it says 2.5 millimeter, so that's what I've used. There we go. So the grub screws, I'll bite into there and stop that moving. Actually, better off if I do it like this. Put something in there so I don't go too deep. I'll know when I get to the bottom. Don't want to go all the way through and mark the other side. I can go back, because I haven't zeroed anything, I can go back to my other setting, which is the other hole to be tapped. third mark is where it's going to be parted off, which right, it's bound up on something. Nice finish. Okay guys, just that pip to take off. Right guys, so we've got the piston pretty much finished. Gudgeon pin is in. I found an M3, an old good quality Umbraco one, and that's a much better fit in that thread than what these things are. I suspect these are just some sort of rolled thread things, I don't know, but I need to get a couple of grub screws and they'll be Loctited in once it's all together. So I've just got to work on the conrod now to make it fit in there. It fits widthways, we haven't got a problem with that. It fits in there, it just won't go down because of this radius. So we'll rectify that, but apart from the rings on it, that is finished, completely finished. No major mishaps, only that I hope I can get the rings on. You've got to spring the rings on, and I have gone too deep, 2 mil, should have been 1.5, but we'll see. I mean, you've got to spring the things apart to tension them to start with. We'll see how we go. If not, I'll have to just use that as a learning curve and start again. Yeah, start again and do it again. But I'll let you know if I do. I'll probably do it off camera and then just show it, or show bits of it. But gudgeon pin, that's like recessed in there, so it's not going to touch the cylinder liner. It doesn't fit the liner. It's still, because that's 24.8 or something, is that. That's got to be honed. So I haven't gone any further with that till honing stones come, and I'll hone that out and hopefully get it out to the size I need, so that this is a you know, reasonably easy push through. We're just a thou or so clearance, or a couple of thou I think it maybe needs. Just, we need to get a good seal, that's all, but the piston rings should do that. So yeah, we've conrod, a bit of work to do on it. Barrel, a bit of work to do on it. Piston, pretty much finished apart from getting proper grub screws for it. So next thing I said I'd try and do in this part 6 is to make the piston rings. I've got a piece of cast iron here that we're over, so that's got to be machined down. Obviously it's way too big, but I think it's the only piece I've got, and it's that piece I bought to do the barrel with. So we'll see where we go with that. I'll make a start on it, maybe trim it down a bit, put a centre in. It might go in 3-jaw, I don't know yet, but the work of that will be done in the lathe. Alright guys, sorry guys, I didn't get round to doing the piston rings in this part 6 because it's going to go on for too long again. There's so much machining and setting up to do and stuff, and I've been trying to show as much as I can. and as you'll have seen the DRO and, you know, centre finding and things, I'm trying to show you exactly what I see. So unfortunately I'll have to make the cast iron rings next time. Okay guys, thanks for watching. Give us a thumbs up. If it's the first time you've seen this channel, go back and start and see part 1. And there's a few builds that we've done. And yeah, subscribe if you'd like. Thanks guys. See you later.